This is a tutorial video explaining the use of a MATLAB code used to solve a problem dealing with circuit analysis. And so the problem is, we will deal with the problem with using Kirchhoff's laws to analyze a certain circuit that have two voltages, user inputs. The user will input two voltage values and three resistance values. And using a MATLAB, we'll determine the value of the third current using a system of linear equations. And there will be an output of a 3x3 matrix that displays the voltages, currents, and resistors. They will only display two voltages, three currents, and three resistors. And then the second task is using the previous equation that we created on the first task, we will determine the minimum and maximum limits to the second voltage using our user-defined function. And then the third task is to determine how the resistance in the third resistor limits the range of the second voltage and calculate the minimum and maximum voltage as well as the average voltage to display them in a command window. And then there will be a plot of graph showing the relationship between the resistance values and the voltage values. And from that graph, we can interpret the graph to answer two questions in the output. So the known values is the user inputs two voltage values and values of three resistance. And it will output the 3x3 matrix, the two voltages, the three resistance values, and also the currents. And it will also display the min and max and the average voltage that we found from our second and third task. Some assumptions we made is obviously the voltage is going to be in units of volts, the current values is in amperes, and the resistance values is in ohms. And for the second task, each resistor is rated at 1 amp, and the three resistors have the same value as the first task. We'll be using the same user inputs. Here's the algorithmic, the list versus the housekeeping commands, and we'll use the VRM file that will store the user inputs, the two voltage values and the three resistance values, and we'll use data validation to make sure that the user does not input a vector or a matrix. We'll be using a loop to make sure, and also make sure that the resistance values are not negative. And from that, we'll create a user-defined function named circuit solver, and from that equation we'll be able to determine our values, our third current value, and use that user-defined function for the second and third task. All of this explains how the circuit solver is, the user-defined function, and then we'll display using the display command or the fprintf command to output the results. And for the third task, we're going to use also data validation to make sure the third resistance value ranges from 15 to 115 ohms. And also we'll use this function created from the first task to find the minimum and maximum for the third resistance value, and also find the average voltage range. And we'll plot it. We'll get to see the relationship between the resistance and the voltage value. Each curve will have a different color, so we're able to distinguish. We have the proper plot elements. And then the last is we're going to display the two questions, and based on how the graph will look like, we'll be able to answer them. Here's an example of a test case. The user inputs two voltage values and three resistance values. And here it will display a 3x3 matrix. Since it's only two voltages, this is empty. And then from there we're able to see what we get for the second and third task. And so this is the code. The problem statement will use Kirchhoff's law to analyze a circuit in order to calculate the currents in the respective resistors and find the allowable limits for voltage using a system of linear equations. So first, task 1 is the user inputs the two voltage values and the three resistance values, and then we're going to call out the function that we created here. Here are the three equations that we've used. The first one is that the third current is going to be equal to the first and the second current. And then from here, we'll also found the two other equations, and since we have the first value, the negative of the first voltage value plus the first current times the first resistance value plus the first current times the third resistance value plus the second current times the second resistance value should equal to 0. And from there we just use algebra to find what's the first voltage will be equal to, and we equal to this. And so we did the same thing for the third equation. And from here we have two matrices, A and B. A is going to store the values of the resistance. It will be, the first row will be R3 plus R1 from here, and then R3, and then the second row will basically be the negative values of the first row, and B will store the values of the voltages. The second value of the voltage will be a negative. And from here we know current is equal to the voltage divided by the resistance. What we get here, the current is going to divide A divided by matrix A, the resistance values, divided by B. This is equal to BA, which B is voltage and A is the resistance value. And so then we just extract the first value, the first row, first column is the value of the first current. Second row, first column is the value of the second current. And then we just add those two currents up to get the third resistance from our first equation here. And so in doing so, we get the values and we just output it to a Excel table, and that's the first task. The second task is finding the minimum and max. And so we have our initial second voltage value. So the initial is the second voltage value, and so we use the for loop and using our user-defined function. And so for each iteration of loops, if the current is greater than 0, then it adds 1 or subtract 1 before running the function again, and it repeats and repeats. And then once the function returns a negative current, that's when we will go back to the previous value and store that to be the min and the max. That will be the max, and then when we calculate the min, it's just reversed. And then we're going to output it using the fprintf command. We'll output the maximum and minimum voltage. For the third task is the resistance effects on voltage. So we're going to reset the second voltage min and max to the initial second voltage input from the user, and then be able to calculate the various min and max values at each instance of the third resistance value from 15 to 115 ohms. So here we are, we restore the values to the initial V2, and essentially we use the same for loop involving task 2, except we add in the for loop for third resistance value to be able to find the mix and the maximum and minimum value of the voltage for that resistance value. This is the for loop for the max and for the min, and once we get that, we display it using the fprintf command and the display command. And then this is the plot. We plot our results, and then we'll be able to answer our questions last. So we're gonna go ahead and run this section. We're gonna input voltage 1. So let's say the user inputs 12. For the second, 9. For the first resistance value will be 100. For the second will be 120. And for the third will be 65. And so here we get a matrix. We have our voltage values as the user input. The third one's empty, there's no third voltage. And from using our user-defined function, we're able to get the current value, the third current values. And then from the second task, using our for loop, we find our max voltage and our min voltage. The max is 34 and the min is 5 volts. Here's an output of the columns of all the values we have for using while we run the for loop for the maximum and for the min here. And then from our third task, we have our average voltage range, which is 34.7. And so to be able to answer our questions here, we have to plot the graph. You can see there's resistance values on the x-axis, the voltage values on the y-axis. The red is the max and the blue is the min. So the question is, what is the relationship between voltage and resistance? As we can see, as the resistance values increases, the slope here is negative, meaning it decreases. So as the resistance increases, the maximum voltage allowed decreases, and eventually the maximum voltage will reach to a point where it equals the minimum voltage. And from that, we could see what would you look for in optimizing the voltage range in a circuit. One, we have to increase the resistance value to be able to increase the voltage range over the range of the resistance value. We're able to answer these two questions based on our interpretation from this graph. And we're going to go ahead and run the section again. And we're only supposed to input one value, but if the user inputs, let's say a vector, it will be, there's an error because this one is supposed to put one value for the voltage, one value for the second, and this is supposed to be positive and not negative. And so we know that this code is able to help with engineers when they have the specific values. They have some values, they have some voltage values, and they have the resistance values, and they need to find the currents. They could run this code to find the current values and find it instantly. The problem is that it's only specific to one circuit layout. It's not flexible to other circuit layouts. And so circuit analysis is important because well, that's how we're able to circuits deals with electricity, and our home, we use electricity power. And so this is our code for the problem of circuit analysis.